Hello, and welcome to TED Talks. Our security edition today is focused on how to detect SolarWinds Cyberattack with Splunk Enterprise Security. TED Talks is a series of short webinars focused on features and best practices. We value you, our customer, and want you to continue on your Splunk journey. Our experts helped create these tips and tricks, and we want you to leverage them in your daily role. I'm Jairo Camacho, a security product marketing specialist. On the special edition of TED Talk, we will share how Splunk Enterprise Security can detect the associated SolarWinds Cyberattack tactics and technique. I'd like to take this opportunity to introduce our co-presenter, Macy Cronkite.
Thanks, Jairo. I'm Macy Cronkite, Splunk Professional Services Principal Security Tech Lead. I've been implementing Splunk security solutions for over 7 years. I'm really looking forward to sharing this talk with you.
Awesome. Thanks, Macy. Today, we are going to discuss what we currently know about the SolarWinds cyber attack, the associated indicators of compromise, how to onboard data sources to obtain greater visibility into your environment. Then Macy will walk us through a great demo to illustrate these points. And then we will cover additional resources to help you utilize these capabilities in Splunk Enterprise Security. Our team will be available for Q&A throughout the presentation over the Q&A feature. And if you watch a recorded version of this webinar, please continue the conversation through the Splunk community website for any follow-up questions. The severity and scope of the SolarWinds cyber attack will take a long time for us to fully comprehend. So far, at least 2 distinct malwares have been identified, Sunburst and Supernova. Last December, SolarWinds, a network monitoring tool, informed the public that sophisticated threat actors injected malicious code into their Orion software. The vulnerability in the SolarWinds software build process has been identified as a supply chain attack. The embedded malware was deployed via an update to the SolarWinds product, providing attackers a backdoor to the SolarWinds Orion customers' information and systems. It's reported that 18,000 customers installed the updates that left them vulnerable to hackers. Confirmed victims include Fortune 500 companies and multiple agencies in the U.S. government, like the Pentagon, Department of Homeland Security, and Department of Energy. When the news broke, our security research team here at Splunk worked tirelessly to ensure customers could leverage their existing Splunk solutions to identify any bad actors attempting to replicate the tactics and techniques used in the attack to potentially compromise your data. Macy will walk us through how to onboard those critical detections to protect your environment.
Thanks, Jairo. The important thing to remember about Sunburst and Supernova and any of the malwares that are following on is that detecting and investigating these type of breaches have a similar framework or pattern. The first thing that we need to do is detect the indicators of compromise. Usually these are IP addresses, domain addresses, hashes, URLs, things like that. Indicators that show evidence that this malware is indeed active and moving around in the environment. Loading those indicators of compromise will show in the demo later. The second thing we need to do for any breach is to review and update the logs that are being ingested into Splunk. Most of the time, these indicators are found in the same kind of log types, such as DNS, network traffic, such as firewall and proxy, and then lateral movement within your endpoint or host traffic logs. And the same is true for Sunburst. Our security research team at Splunk developed a simple way for us to load IOCs for Sunburst into Enterprise Security, and we'll show you that in a moment. Once you've found malware in the environment, an important thing next is to start looking for evidence of the malware moving around in the environment with other sources of data, like vulnerability scans, looking for hashes of files that are indicators of that file being in the environment. Finally, once you've seen these indicators, or if you see these indicators in the environment, you'll want to start looking for unusual activity within your user groups, your hosts, perhaps new servers are being stood up, perhaps new admin users are being created, that's really an indication that the hack or the malware has exploited what they want to do, which is to leverage your resources and your networks. And then you want to look to see if there has been any sign that that user or account or server has gone on to do other things within the environment. As it is with Sunburst and most other malware type breaches, there's some common data sources that we can leverage within Splunk to look for activity. In this case, our security research team put out a blog post that specifically calls out some common data sources. The first one is using Splunk Stream for DNS data. It's an easy way for the Splunk Universal Forwarder to capture full DNS traffic and make it SIM compliant for enterprise security. In your DNS data, you're looking for indicators like the source IP, a domain, or a destination IP, indicating that the malware went out to the websites that it wants to contact. Another very popular data source used for indicators of compromise is Microsoft Sysmon data. It's an enhanced logging that needs to be enabled on your Windows devices. In this case, Sunburst is indicated by event codes 17 or 18. And this is I'll show you how to look for these. Another feature of the Sunburst malware is that it likes to pivot and start to leverage your Azure infrastructure, creating new system accounts, creating new servers to leverage for its own activities. So looking inside the Azure AD audit log for new and unusual activity, hosts that you're unaware of, accounts that you're unaware of, is an indication that the malware actually moved on and started working. VPS stands for virtual private servers. So if you're using those in your environment, you'll want to look for unknown new computers, new hosts. As I mentioned before, firewall and proxy are really the bread and butter of finding these types of attacks when they're active. If the Sunburst malware was in the environment and it started to call out or beacon home, you'll see this in the outbound URL or outbound destination IP address. And that's what these indicators of compromise that we'll download later show. Domains, IP addresses that we can match on. And then finally, another piece of data, a very common log source that's used to look for these attacks is the Microsoft PowerShell. This is another extended logging capability of Windows that needs to be enabled. So if you're logging PowerShell, that's where you'll see where the malware starts to move between devices. As I mentioned earlier, malware and breaches are part of the landscape today, unfortunately. Cyber attacks happen often, they regularly occur, and luckily enterprise security has a native capability within it to quickly download IOCs, these indicators that usually consist of URLs, domains, or hashes, and integrate them quickly into your enterprise security platform. Inside enterprise security, these IOCs are placed within our threat intel framework. Those lists are labeled, categorized, and weighted, and matched against MITRE attack tactics and techniques. And they are kept in the environment so that you can continually scan for these and create different reports or notable events or different adaptive actions, or even leverage Phantom to create responses. Security teams everywhere are unfortunately all too familiar with these types of threats. I think what we're seeing now with Sunburst is a different approach with cyber attacks, and that's probably why it's very important for us to think about how this particular malware got in. For the first time, we're starting to see an attack on the supply chain where this software wasn't a hostile new EXE that had never been seen. It was embedded within known, valid, authorized software. So that's a new pivot point that we need to start looking at and start to think about how can we add additional log sources that cover the DevSecOps software lifecycle. So new data sources that should be added to Splunk would be around the supply chain. We have to think about also how can we scale the SOC. One of the features of Sunburst is that the malware started in the environment back in March of 2020. So looking for these breaches may require a large historical look back for these IOCs. So scaling up quickly the SOC environment and preparing them to be able to respond quickly to this kind of threat is something that's new for this one. We're also seeing a loss of IT visibility because SolarWinds is such a critical part of IT monitoring. With that lights out, it's about how are we going to replace that missing log source, and even how does that impact our detections for future breaches like this. So, we're starting to see more and more where we're going to have to look at our trusted vendors, our supply chain, and which third-party softwares we're using in our environment, and whether or not they're being logged. If something like this happens again, it will be the case that they may be in the environment for a year or more. So having that historical log trail is very important for the breach response capability. I'm going to show a real quick demo here on how to download the Sunburst IOCs and load them into enterprise security.
And now I'd like to show you how to implement Ryan Kovar, our principal security strategist's blog in enterprise security. So this blog was posted last month in December of 2020, and it gives you a great overview of how Sunburst works, all the background, and in the middle here, they have put together several threat files. These threat files are CSV files, which are available here on GitHub, and they consist of some pretty simple files. This one contains domains, IP addresses, and hashes. So I want to show you how to implement those in enterprise security. So the first thing you want to do, of course, is download these files, get them ready to upload. And then you're going to want to pivot over to your enterprise security platform. Inside of enterprise security, there are a couple of places that highlight IOC lists like this. But the first place I want to go is inside configure. So you go to configure, content, and in here is data enrichment and threat intelligence uploads. This is pretty easy. Just upload the file. I'm going to grab the one that has IP addresses first. So when you upload a file like this, you want to give it a weight. If this is really important to you, maybe this weight should be higher. I'm just going to leave it at a 5, somewhere in the middle. I'm going to label this, give it a category as Sunburst, and I'm going to put it in the SolarWinds group because there's lots of different IOCs. There are new things coming out all the time. This one is looking for Sunburst, but now we might be looking for things like Supernova. So I'm going to group it as SolarWinds and give it the category threatless, Sunburst. Give that a save. Now I've already uploaded this file. Let me grab another one. I grab the domains one and do the same thing. 5, I'm going to put it in the middle, Sunburst SolarWinds. Great, I've got this file uploaded. Now I want to make sure that this file gets recognized by enterprise security. So let's see, the first domain in here is dftsecurity.com. So I want to make sure that that actually gets folded in to my threat artifacts within enterprise security. So the page that I go to do that is under here, in security intelligence, threat artifacts. When you upload a CSV file like this, it's going to get folded in to the threat intel framework. So what we want to do is make sure that it gets uploaded and recognized in here. Sometimes that takes a moment or two. You can see already I have my SolarWinds threat group here. That's good. I see my Sunburst threat categories. That's good. Let me see what I have so far. Sometimes it takes a moment. So this is definitely a step that you want to make sure works for you, depending on the size and scale and how busy your environment is. So you can see my Sunburst domains list did get uploaded. So I love that. That's great. So what's going to happen now is each one of these domains is going to get matched against its IP address or its domain name through incoming and outgoing data. So places where this could possibly match is going to be most likely firewall data or proxy data. You might still also see this in stream data. You might see this in endpoint data, especially if you've already blocked the firewalls or already put rules in place. So looking for this further in the stack is valid and interesting. So this is a great sign. I want to show you a trick as well. So something you can do to just extra confirm is grab one of these addresses, and you can maybe in a sample environment or someplace that you want to test things out, you can actually do something like this little trick we have. You can use the command make results, pipe to any eval command you want. In this case, I'm going to set up some dummy data that says the destination IP address is one of the ones in my IOCs, and I'm going to collect it to an index. This creates a dummy event that contains that field. So this will help me later be able to pick up this IP address. So I can test my rules right now without having to actually have this in my environment or having to go out to those IP addresses. You may also want to add what I'm doing here now is simulating the tags of the firewall data. So all firewall data usually comes with the tag, network, and communication. And I'm also going to append those in. So this is a great way for you to be able to test the rules and set them up. So at this point now, I've got my threat intelligence inside my threat artifacts that came from the blogs. I've made sure that they're in the environment, that they're being picked up correctly. So now I know that enterprise security has these. And I've set up some dummy data where the rules could actually fire on. So let me show you where the rule is. So go to configure, content management. And in my opinion, this is probably the most important rule in enterprise security because of how powerful it is and how wide-ranging it can be. So it is called that. And I'm going to pick the type correlation search, and here it is, threat activity detected. I want to make sure that this one is enabled. Nothing yet has fired because I haven't set, it hasn't run yet. And in here, I want to make sure that this is looking at the right time. So just so you know, out of the box, it looks back about an hour, and it runs every 10 minutes. So we probably haven't seen this run yet. I want to note to you that this out of the box, or the way it's set by default, will only fire on each IOC. So if it finds one of these addresses or domains, it's going to sleep effectively until the next day. Now, I probably want to add some adaptive responses, most importantly, a notable event. And you may want to change these settings specifically for sunburst. So you may want to update these a little bit, or update the search if you want to prioritize these sunburst higher or lower. That's part of what the weight field will do, but you may want to add some extra information or extra fields. For now, this is okay. I'm just going to leave these as is, but because I know that sunburst is so important these days, I'm going to just go ahead and add an email as well. This may get a little chatty, but we're looking for something and we want this immediately. So that might be an option for you, and you can go ahead and hit save. That way you get this as extra. If you've heard anything about risk-based alerting or risk analysis, this field basically adds some points of risk to the source system that is detecting this event. So if we have these IOCs going out, we will append some 40 points of risk to the source system. So this will help us prioritize and identify, group together source systems that are having the same issue or going out to the internet to the same IOC. That's it. That's pretty simple how to get it into enterprise security. There is a report here under security intelligence, threat intelligence, and threat activity. So once we've done these 3 steps, step 1, upload the CSV files into enterprise security underneath threat artifacts. Then we want to confirm that in threat artifacts our CSV files appear. Then we want to make sure that our correlation search for threat activity detected is enabled and is set a way we want. And then here in threat activity, we can get an overview of all the collections or all the different feeds that we're tracking.
Thank you, Macy. We have some great resources available here for you to learn more about how to detect SolarWinds Cyberattack with Splunk Enterprise Security. Check out these resources. They are filled with great insights. You will receive these assets as well as this recording in a follow-up email. If you are watching on demand, you will find them in our community for this TED Talk. Also, don't forget we have an incredible community of Splunk users on our community website. There you will find a Q&A section that you can use to learn more about detecting SolarWinds Cyberattack with Splunk Enterprise Security. Also, feel free to participate in this new discussion section with Security TED Talks. And finally, you can view Splunk Ideas, the place to submit any new ideas you might have for product enhancements. We really appreciate you taking time out of your busy schedules to join us today. Please tune in for future TED Talks. We're excited to share this series with you. Thank you again.